Hello learners, welcome to a bite of learning. In this video, I'll talk about a recent interview question for generative AI role. So the question is, why can't we have a re-ranker type cross encoder at the embedding system? Why a Bi encoder is used to create embeddings? If you understand, this is something related to RAG, which stands for Retrieval Augmented Generation. Now, in this very specific case, in the RAG, you need to understand what is the fundamental flow. And when you understand the fundamental flow, you will understand where re-ranker is used and why can't it be used at the initial step. So we'll discuss first a basic RAG overflow. It looks like this. You have a query, and based on that, you will do a semantic search on top of a vector database. This vector database is prepared from your knowledge database. From the knowledge base, you are going to chunk, and the chunked documents are going to be passed to a Bi encoder. That Bi encoder is gonna give you vector embeddings, and those vector embeddings are stored into vector database. This is going to be the initial step. Once that is done, then you are ready for query, and you give query on top of a semantic search, and then you retrieve some documents. For example, here top k, I take k equal to 20 retrieved documents, but I can't pass all these 20 documents to my model to summarize the result. The problem is there will be too many. Second thing is all these 20 are not relevant, not exactly relevant. So that's why you get a re-ranker here. The goal of re-ranker is to find the most relevant documents, the yellow ones here you can see, which are very relevant to your query, and then pass it to the re-ranker documents. And these re-ranker documents will be passed to the generative model to generate the answer, and thereby you have the answer. This is the basic RAG overflow. So for the re-ranker, we are going to use something called as cross encoder. Now, the question was, why was cross encoder not used in the embedding generation step itself? So the reason here is pretty simple. Cross encoder first cannot give you a sentence embedding out. The goal of cross encoder is to take two documents, two sentences, and give its similarity. In fact, from the sentence transformers, this is the architecture given. So the idea behind cross encoder is you can pass sentence A and sentence B. It acts like a classifier to give you what is the sentiment score. So because of that, here you are going to, in the RAG very specifically, the sentence 1 is going to be query, and the sentence B is going to be the retrieved document 1, retrieved document 2, because here you have got 20 documents. This 20 documents you are going to pass here. So this cross encoder is very special. It compares both query and the retrieved document, and it makes it so perfect and so accurate according to the context. And because of this itself, the interviewer tricked you into asking why cross encoder cannot be used at the initial level. It cannot be used because in real time, if you are going to pass your query, and here your chunks will be thousands of chunks, and passing the query and 10,000 chunks to the cross encoder as the user is waiting for the query is impossible. That is the reason you have a Bi encoder here. What is this Bi encoder doing? Bi encoder is generating a vector, which is a contextual vector, which is as close to real life, as close to context as possible. So Bi encoder's job is to generate the vectors very close, and you get the similar vectors. On the top of similar vectors, you use cross encoder to double check the similarity or quality using a cross encoder architecture, and you finally predict the model. So you cannot get cross encoder to the Bi encoder place because it takes so much time for all the millions of documents and the query to be passed in real time to calculate similarity. That is the reason we generate vectors and do the vector similarity first, which is really fast. And for the accuracy purpose, we are going to use cross encoder. And this architecture, the initial architecture is prioritized for speed, and the next part of the architecture is prioritized for accuracy. This way, we have both of them at same place. I hope you understand this, and I hope you enjoyed this video. Thanks a lot for watching.